I'm Jamie Ullman. This is my video for Distinction Task 8.1D Raspberry Pi I2C for SIT 210 Embedded Systems Development at Deakin University. In this task, we connected our ambient light sensor to our Raspberry Pi using I2C serial communication. I2C stands for Inter-Integrated Circuit, where data is transferred bit by bit along a single wire, in this case the SDA wire. We've used an ambient light sensor, so we're using I2C to read the environment light intensity of our surroundings, in this case an office. Firstly, let's look at our circuit. We have the respective voltage and ground pins connected respectively to the pins on the ambient light sensor as they are to the Raspberry Pi. We've then also got SLC and SDA pins here at pins 3 and 5 connected to their respective pins on the ambient light sensor. The SDA line is the one which the data will be transferred along, whereas the SLC is where the Raspberry Pi is going to be sending data to this about the time for the clock. You may also notice we've got this small wire from the ground pin to this address pin, and this address pin allows for an I2C address. Now if we look at our code, we've imported two libraries, the SMBus and time. We've got a couple of constants here. We've got the bus, which is setting up for the I2C serial communications, and that's happening along via a systems management bus going back and forth along the SDA wire. Then we've got our address for the ambient light sensor, which is at 0 times 23. We've then got our function here, which is read light. That's going to the address of the device. That's 0.23, 0 times 23, sorry, we've got before. Then it's going to be read once it reaches the Raspberry Pi after it's returned on the bus along that SDA wire. And then whatever data we get here is then going to be calculated using this function here and then return a result. We're then going to go into a while loop, which while it's on is going to read read light level as light level, and then print that out to two decimal places, I should say, with the units LX for lux. Now if it's under 20, it's going to print 2 dark alongside that. If it's between 20 and 100, it'll print dark as well. If it's between 100 and 200, it'll print medium light. If it's between 200 and 500, it'll print bright. And if it's above 500, we're going to get 2 bright. We've then got time sleep for 1, so it's going to read it every 1 second. And then finally we've got accept keyboard interrupt, so if we pressed Control C, it will print measurement stopped by user.